Okay, this will be the final installment for the Media Links actuator servo system here. A couple notes for you, Frank, real quick. Here you can see there's on the rotary amplifier, we have my power that I have coming in. I'm bringing that into L1 and L2, and I have a jumper between L1 and L1C and L2 and L2C. That's the motor power and the control power. They both have to be powered on. You can do it any way you want to. You can actually have it go through a contactor, so that way as soon as the machine starts up, the control power's on, and then as soon as you pull the E-stop out, the L1 and L2 come on, or have it both come on at the same time. It doesn't really matter. But that's where you want to bring your 110 volts, or you could do 220 at this point. It doesn't really matter as long as it's a single phase. Here you have your Mechatrolink line. Your Mechatrolink is what communicates between the motion controller and the rotary amplifier, which then the rotary amplifier will send the information down to the servo motor, the SGM JV Yaskawa servo motor, for its incremental or absolute type move or whatever we're doing. As far as the cabling goes, you have your terminating resistor on both sides, and it doesn't matter how this cable's put in. There's two different slots. You put it in either slot. It doesn't matter as long as you have the terminating resistor on each side. If you had more than one servo axis, we just have to have it end with the terminating resistor and then have it just jump to cable to the next machine, whatever you got to do. But in this case, we have a single axis. So terminating resistor here, doesn't matter which slot, just make sure they're put in. For your motion controller, here we have 24 volt DC brought in here. So you have to supply the 24 volt DC to the thing. The dip switches, I leave them exactly how they are. I have them configured just the way you need them. For your I/O, the only input that we actually have right now, and again I apologize for the urban rigging here, but we only care about this wire right here, which is yellow with 3 short black, and the white with 3 short black. Okay, the white with 3 short black needs to go to your common, and the yellow with 3 short black is your digital input 0, which is the input that I'm using for triggering. So whatever you wire it up to, 24 volt, will go into this wire right here. Let's go ahead and turn it on real quick. Okay, communication-wise, Ethernet. It doesn't matter if you have a crossover cable, patch cable, whatever, as long as it's the Ethernet cable, we're going through the switch. So we want to bring one from the motion controller to the switch, and then one from the switch over to the HMI. And there's a slot right in the bottom there. Besides the cable to the HMI, the only other thing you need is your 24 volt DC, which will be brought into the side over here. So again, this is the program. It's all embedded. We have, just to start off with, let's see here. We define the axes, which in this case we only have one axis. It's your lift axis right here. So once that is defined in the program, which is pretty simple code, we pull out all the information we want from that axis, which includes the torque, the position, all the other goodies. We have a lot of logic in here just for maintaining its moves and to know what mode we're in while it's actually actuating. We also have our conversion between the HMI screen over to the motion controller. So we're taking the data that's going from a word to a long reel or whatever we're doing, and then our main program, which is just running pretty much all the functionality here you see, which is all the jog moves, position absolute moves, everything we have in there. And same thing with our safeties, so we don't go on past a certain point. Because again, we have 292.1 millimeters of stroke, and that's leaving about a 1/4 inch on either side of a deadband, so that way we don't hit the hard stops inside. So with the screen, just want to show you one more thing real quick here. Setup. It's always going to remember these positions. Okay, so it's say you power down and you wanted 2 millimeters per cycle, or 1 millimeter per cycle, or 0.1 millimeter per cycle, or 0.05 millimeter per cycle, whatever you have. It's going to remember it on power up. Same thing with your signal maintain and delay times and everything else. All those will be remembered. The only thing that will be lost is the cycles ran. And then again, once it starts, it doesn't know where it's at because this is an incremental encoder. It's not an absolute. So it always just assumes it's at position 0. So as soon as you put it in mode, it's going to start heading backwards. It's moving back. And as soon as it finds its home position, it's going to reset itself to 0 after it does this offset. So, in a nutshell, that's it. I'm about ready to tear it down and ship it out. Call me if you have any questions. See ya.